just how important coupling is when simulating at extreme scale and computing very, very complex problems. So just at the bottom there is a link, and I'll put this link up again later, to this particular project. And so this project will be running over 3 years, and you'll find updates there as we go of different events that we'll be holding. So just very briefly on the ExCALIBUR program. So some of you will be familiar with ExCALIBUR, and for others it may be new. But ExCALIBUR is the UK's Exascale computing program. So it's supported by UK Research and Innovation, the Engineering and Physical Sciences Research Council, and also with significant engagement from the Met Office and also from UKAEA, the UK Atomic Energy Authority. So it's a 5-year program, and it's focused on algorithms and infrastructure for exascale computing. And what I've listed there on the bottom left are 5 themes that the ExCALIBUR program is structured around. And so there's knowledge integration, high priority use cases, emerging requirements for high performance algorithms. And the 4th one is the stream that's funding this particular project, which is on cross-cutting research. So there were 5 themes identified that were cross-cutting themes to underpin exascale computation. Coupling was one of those, and this is the project that was funded to explore coupling technologies. And there's also work going on around proof of concept and novel hardware. What I've listed on the bottom right, and I know it's difficult to take these links down very quickly, is a link to a mailing list for ExCALIBUR announcements. And Chris will send a message later. He may have sent one already, but he will send one to all participants with that link. And that link is you can follow if you want to keep track of what's going on in the wider ExCALIBUR program. So this particular project is this integrated simulation at exascale, looking at coupling, synthesis, and of course performance. And the main objectives of this proposal were to develop mathematical methods and software tools, looking at identifying both of those as very important, in fact equally important, that will support coupled simulations at the exascale to solve challenging problems. So we really are striving to have a balance between fundamental, rigorous mathematical methods with efficient, open software tools to be able to tackle a range of challenging problems. So the project is a 3-year endeavor, and it started on the 1st of August of this year. So the 4 institutions that are involved and we're contributing to the research in this project are, of course, University of Cambridge, which is where I'm based. We also have UCL, University College London, Science and Technology Facilities Council, where Stephen is from, and University of Manchester. And then in addition to the 4 project members, we have a range of partners, and I'm really delighted that a considerable number of these partners are actually presenting in the workshop today. So these are partners who agreed to provide support and advice to this research project. And so partners who have a deep interest in the problems we're going to be looking at. So I just want to summarize very quickly the program of work that we're going to be undertaking over the next 3 years. So I've already highlighted we're looking at mathematical methods and software tools. And the 4 themes that the project will be structured around are listed there. So the first one is around stability and accuracy, with a particular emphasis on high order methods, with high order methods being one of the directions where consensus is building that is necessary for exascale. We're looking at coupling libraries, and at exascale, it's very difficult then to not be thinking about heterogeneous architectures. So we'll be very interested to hear today what work is going on in that particular direction. Portable and reproducible deployments. Once you talk about coupling and you've got different libraries, you've got different systems, I think in many ways, the challenges around portability and reproducibility are very much amplified. And so we do have a small work stream just to think about what are the best ways we can tackle that particular challenge. And then we're going to structure our proposal around a number of high impact demonstrator applications. So the applications in their own right are very challenging, so we won't be solving these problems, but we'll use them to guide our developments. If you look on the bottom right, it's a simulation that was carried out as part of an earlier ExCALIBUR project by Timo Beckter at UCL, and that was looking at virus simulations. In the middle, we've got electric flight concepts. And on the left, we have a fusion reactor. So these are three highly challenging, highly relevant problems that we'll be using to direct our research throughout this project. So on the workshop schedule, I've put up the list of speakers for today, and I'm really excited. We've got a fabulous range of speakers. In fact, when we put the proposal together and we surveyed the leading tools and libraries for coupled simulation, the ones we listed are all the ones you see on this slide. So I'm delighted that we've been able to get developers of each of these libraries to come and speak today and to give us their views. I've posted at the bottom there a link to the workshop page, which is where you'll also be able to find this schedule. So just finally, around the ExCALIBUR project, for updates on this particular project on coupling, we'll be posting updates and further events, and there will be a wide range of events happening over 3 years, so you'll be able to find those at our webpage. And again, if you would like to follow the wider ExCALIBUR activities, there's a link to the mailing list at the bottom, which again, Chris will distribute later. So what I'd just like to say is, as we've got a number of speakers today, and we're running in webinar mode, and so if the audience members have any questions, please put those in the chat. And what we'll do is, time permitting, we'll put those to the speakers at the end of each presentation. And if we do run out of time, I'm sure that the speakers will be happy to answer the questions in the text boxes after their presentation. So thank you very much. And what we'll do now, we'll start the workshop, and Stephen Longshore is going to chair this first session.